Okay, so welcome to the second part of the technical track. We are running just a few minutes late, but I guess this is the group that is going to join us today for the second part. In the first part, we look to how to manage the data, how to organize our data. We look to federative aspect. We look to how can we build application on top of openEHR data. Also, we had a presentation about open source implementation of openEHR. Now, in the second part of the track, we have 3 presentations about the use of data. So how can you get the best functionality on top of openEHR data? First is Rong with the clinical decision support. So Rong, you have the room.
Yeah, thanks for the introduction. Can you hear me all right? Okay, good. I'll be standing here. I need to do some demo afterwards. Welcome to this session. It's going to be about clinical decision support systems. Let's get started. I always try to use this slide to describe the systematic kind of challenge in our industry. This actually is not new. This has been around since the late 80s, beginning of 90s, when digitized systems were introduced into reality. At that time, people like me, the informatics people think, okay, we have a chance to move the knowledge and information around in order to prove the quality of care. So essentially the idea is that with digitized system, all of a sudden you have possibility to move computerized knowledge to the practitioner at the front line, overcome the so-called dissemination challenge. When they measured, it actually takes 17 years in delay, and to help decision-making in the front line with a general practitioner, with specialists, and so on. And there are lots of publications, theories about decision-making, flaws in human being with unaided decision-making process. People easily get distracted, people get fatigued, there are different kind of fallacy in decision-making. So essentially, this is the kind of systematic kind of challenge we're facing. And one key word I want to use throughout my presentation is about scalability. Anyone can do one application, one decision support application. Anyone can do any, with any programming language. The challenge really is the scalability. How we can overcome these challenges, use others' work, reusing clinical models to produce these things with high quality, with rapid process. This is really a challenge for us as a community. Let me take a step back and review what is clinical decision support system. So this is a good description. I mean, there are all kinds of flavors, and this is the one I like. That there are 2 keywords. Essentially, it's about combining what we know about this patient, what is the knowledge say about the current practice. Essentially, it's about linking this patient in front of you, what we know about this patient, and the best practice, and provide a timely recommendation in the right context. So it's about combining these 2 information. I will get to the theory in the next slide. And then there are specifics. I don't think we can boil the ocean in one go. So our approach, at least, we go for the low-hanging fruits, where it really matters. And typically, these decision opportunities, they are spread in the clinical process, in longitudinal process like type 2 diabetes, heart failure, and so on. But some of these moments are really more important than others. And those will be the low-hanging fruits for us to implement decision support, introduce the intervention. Some of them are to do with this systematic kind of pressure. I mean, we come from, my company is a Swedish company. We operate mostly in Nordic markets. But I don't think EHR-specific solution is going to be the answer. It needs to be EHR agnostic. It needs to be operate on others' platform. So that's the approach we took early on when we started this journey 8 years ago. And the system can't be a standalone system. The decision support system can't be just a standalone silo. It needs to be fully integrated. By that, I really mean existing patient information in the local clinical system has to be used, taking into consideration when new alerts are raised, when the decision application provided. And often we have this combined approach. We raise alerts at the right time for the right user, and we bring the user attention to a special purpose craft single screen application. Put all the information and knowledge piece into one screen and guide the clinicians through the decision-making process. And design all the flexibility into this single screen application. So it's always user-centric, and it's very specific design for each application. We don't believe one-size-fits-all approach. So every application has to be crafted design-wise. This is a paper more than 20 years old. Sometimes it's quite amazing when you think about these good ideas. They're just long-lasting, and they're very simple to explain. How many of you have seen this publication before? Almost no one. One, two. Of course, Sebastian, you know that. So this is one of publications from Professor Alan Rector's group in Manchester University in the UK. The idea was quite straightforward. When you process any kind of clinical medical data, you need to deal with three principal models. We already mentioned information and knowledge. Information is quite straightforward these days. If you look at the top part, we have approximation to access this patient information through openEHR, through archetypes, sometimes through FHIR resources and so on. When it comes to knowledge, it has two parts. Sometimes we say slow-moving background knowledge. Those are codified in terminology like ICD-10, ATC, and this is more often SNOMED CT type of ontology-based terminology systems. There's another kind of knowledge. Often we don't talk too much about that. We call these things foreground knowledge. That is what is the latest treatment for heart failure patients, how to manage arrhythmia in order to prevent strokes. Those are relatively fast-moving compared to the background knowledge coded in SNOMED CT, ICD-10, and so on. When you do decision support system, when you do analytics, you really need to process all three of the models, essentially, approximation of the reality. And you need to craft a well-crafted interface of these three systems. That is the theoretical kind of starting point for us. It really inspired us to look into how can we do decision support in a scalable way. Unfortunately for us, when we started the journey, I think it was almost 10 years ago now, we didn't find any reusable design in the open domain that can help us with this knowledge representation for decision support purpose. So we end up creating something based on the openEHR foundation, using archetypes, archetypes-inspired design. We call this guideline definition language with bindings towards data points archetypes. We have rules expression. You can run these guidelines sequentially. You can run them in parallel. There are rules engine behind this. There are editors. You can run these guidelines. You can run simulation. You can test them well. And those are building blocks for us. We really use them everywhere in our production systems. The first version was published through openEHR 2015, and the second major version was published 2019. And just early this year, it went through the stable status tag, thanks to the community. So this has been the main specification we use as part of the CDS product. When it comes to scalability, we also need to test that in the reality. And this is something we have been doing with our limited bandwidth, with the community, with the students, medical/informatics students locally in Stockholm with Karolinska Institutet for many, many years. I think we've been organizing, that's the next slide. We're organizing what we call App Challenge for the students that we're facing for 7, 8 years now. We're relaunching this now with our new generation of tools. So the idea is very straightforward. For those informatics students, sometimes first year, sometimes second year, come to us, we give them the tools that we use for production, for CDS development. They take our tools, they bring their own requirements, and they produce these simple calculators, sometimes full-fledged decision support application. And we publish the result in the GitLab community project as open source software. So here's the listing of these models. They are put neatly in different clinical specialties. There are more than hundreds of them after, I think, a 7-8 years period. This is our website for this. It used to be called Summer App Challenge, but now we scrapped the summer concept. It's App Challenge year-round. We just organize students. I would love to have participation outside Sweden. So if you somehow can involve students in your local universities, please get in touch with us. We love to support you guys run this kind of app challenge and support open source project. So how to put this together in a sort of commercial grade CDS application? How to put these models together? I mean, we're running 100% model-driven development, rapid kind of process, and we still want, in the end of the day, want to get through this MDR, medical device regulation process, to get the high-grade, high-quality application. So how we do that? These are the models, these are the building blocks. It's 100% all the decision logic, all the UI behavior, all the UX, they're 100% driven by these models. There's no low-level programming code ever. It's always driven by these models. And the really starting point is this archetype and templates as approximation to the patient information with a path. Sometimes we use queries to pre-fill app UI, the form. Then we build specific application front-end for this decision support purpose. Sometimes it's a heart failure, sometimes it's a prostate cancer screening, sometimes it's about a rare disease referral. The GDO guidelines are used to represent clinical logic, and that's where we put lots of effort to model the evidence-based guidelines, the practice guidelines. We put them into the rules format with bindings to sometimes open the archetypes, sometimes to file resources. And we have a test framework with always reach 100% test coverage, and we have automation in the pipeline to run the tests all the time. And that's how we get to this high quality, even with rapid development. On the boundary, we use CDS hooks, smart app kind of a protocol to launch our app in the hosting clinical system. It's not only our own EHR system in Sweden. We have successful integration in Denmark, in New Zealand, and we have a pilot in UK. So this is all, all the models that we use in this model-driven development. And the process looks actually quite similar to any kind of software development. The part that is like radically different is the middle part, is the modeling. Any questions so far? No? So let's get to the demonstration. I have lots of screenshots just in case the connection doesn't work. This is our approach. Unfortunately, there's it's also called CKM, but it's a Cambio Knowledge Manager. So in this environment, you can see on the top navigation, we have all these building blocks I just mentioned in the slides. Archetypes, templates, sometimes we use file questionnaire response. Queries, archetype query language. Forms is our sort of user interface for the applications. And GDO guidelines, we also start to explore order sets. So this is a OPT 1.4 template used by, as a kind of template for the prostate cancer assessment. So the use case in this decision support is the oncologist, when they get a referral, when they have the pathology report from the lab systems, they look at this case, they make assessment. Is this patient going to get a curative treatment, or should be kept in observation, or maybe go through the palliative care? So it's a risk assessment plus treatment recommendation use case. And we bring everything into one screen. And this template in front of you really capture all the kind of concerns with data input and so on. This actually is crafted with Better's Archetype Designer. We don't have editor for these templates ourselves. The second component is the form. Once you have this template for the data points based on openEHR archetype format, you want to craft a form, a kind of web user interface to support the decision making. So I'm going to open this here. This is our form builder. The principle is the same as other vendors' form builder. Essentially, it's a drag-drop interface. It's a low-code, no-code development environment. What's special in our kind of form builder is that you can also couple it with decision support rules. So the decision support rules can process both the pre-filled data in the form, but also the data entry by the user, and reach a conclusion, reach a recommendation, and so on. I'm going to show the preview format. Here you can see when you have data input, it will auto-generate openEHR composition, and then the composition will be pushed downstream at CDR or persistence layer. And there's a piece I want to show you here where the decision support logic are captured. It's also hosted in Cambio Knowledge Manager, connected with our guideline editor. So this is how it looks like in the guideline editor. This work is a prototype, so you don't really see a lot of metadata. And here you see the binding. This is all the data points are based on the archetype. So here you can see, you can pick the interesting data points to build upon this archetype. And you can use that for the rule reasoning in the decision support application. Here you have the output. And typically, in our production kind of ready application, we have multiple guidelines. They are sometimes sequentially chained. So the result from the first guideline will be used, fed into as input for the second and as third guidelines and so forth. Here you see the rules. They're not very difficult, every of them. But when they're combined, it really adds a lot of complexity. So therefore, we have built-in tools to actually generate simulated environments. So you can actually run single guideline in this simulation. You can run this guideline, simulate input from the end user, from a source system. Then you can get the result. You can capture this result, and you can automate these tests. Here I have a run of the limited test case I have here. It shows the coverage, test coverage of the rules, only 17.6%. In our production development, we always reach 100% with all the combinations. Now I think I can show the end product. So you see, I run this application now in the browser, but most likely this will be embedded in some kind of clinical system, either in Cambio's own EMR system or some other clinical system in other market. As I said, the use case is about risk assessment in prostate cancer, so it's an oncologist kind of use case. The oncologist will look at the lab test value, PSA value, the PSA density, and some pathology reports on the staging and the biopsy and so on. So with this input, the CDS recommendation is it's intermediate risk. And the recommendation, you can read here, what kind of treatment will be relevant and so on. It appears in narrative because that's the requirement. I mean, we actually developed this together with oncologists. So you think, okay, it's very low tech, why you get the recommendation free text? But that's what the user want in this particular case. There are other cases, we actually generate referrals, we automate the care plan generation, we can generate lab tests using standard building blocks like file resources, openEHR composition, and so on. And this is fully interactive. You can actually change the input. And I think if the session, maybe the session gets timed out, just rerun with some other data. Yeah, so this is low risk, and the recommendation according to the clinical guideline is keep active monitoring without any treatment. I will stop the presentation now, the demo here, and yeah, open for questions. Thank you.
So questions? Didn't saw any. Okay, maybe I should then ask something. I know that you also use FHIR data and also openEHR data. I wonder, how do you normalize, how can you compare one data source or data coming from one data source with the other one? Do you have anything that is facilitating something like that?
Yeah. Actually, the answer is very straightforward. I'm going to be very honest with you. Sometimes we don't get pick. I mean, we have been operating for 7, 8 years now. So in the market we operate, sometimes we don't have choice. I mean, we have to support FHIR. So we don't really have the mapper my teacher presented earlier. I mean, we just use the source model. But we try to keep the FHIR resource at the boundary with the prefetch, with the CDS hooks and so on. And internally we use openEHR archetypes and templates as much as possible. But it's always practical choice, right? Yeah.
And all these guidelines are computable kind of a scripting things, so you can also run in a different application once you have the implementation, of course, of the guideline.
Yeah.
Correct? Yeah. So
yeah. And most of these guidelines are very straightforward to computerize. Sometimes they come with decision table, sometimes they come with a graph. So it's quite straightforward to computerize that into GDO format.
Yeah. Okay. Any more questions?
Yeah, please.
Do you have some thoughts on using AI or ChatGPT combined with the guidelines?
Yeah, well, definitely. I mean, this is a question often got asked. There are different reasons we are hesitating, we're exploring. Actually, we have done prototypes with hybrid approach. With the predictive model, like machine learning models and so on. Typically, it's a black box. And it will be very tough to get through the MDR process because you need to produce evidence, the clinical risks, and so on. But there are cases when there are no existing evidence, like predicting admission, predicting how long the surgery is. So sometimes we do think the hybrid model will work. Some of our decision support systems have this risk prediction for stroke, for other things, based on past data in the registry. And that's the area I think the predictive model can really be a good choice. Then we provide this hybrid, some kind of predictive model-based prediction percentage. Then we have rule-based part to really give the confidence to clinician. Does that answer your question?
Okay. Then thank you.
Thank you. Thanks.